Hi my friends, today we try to model this assembly made of two objects. As you can see, the contact between them is by this spherical end, which goes into a spherical hole. You can move this mobile component so that we have a stand and an eccentric mass. This is the stand with that spherical bottom and eccentric mass, which is this one. We model the two parts, we create the assembly, and the goal is to apply dynamic simulation. I activate for you the dynamic simulation module from Inventor Professional. This module has already been set so that when I start the play, we see what happens. You see, there are contacts between the two objects and everything is very natural. Nothing is exaggerated or forced. I go back, I finish dynamic simulation on this assembly, and we start by creating the stand. Two discs with diameters of 120 and thickness of 12. The distance, let's measure the distance between the two, is 212. Other measurement between the internal faces is 200. Okay, let's start with this bottom disc. New, standard millimeters IPT, start sketch. We start with this sketch, with this plane, and with a circle of 1, 2, 0. Finish sketch, extrude 12. Okay, now I place a plane based on this at 200 up. Home, and we see the other plane of work. I project this circle and I have a sketch. I can apply extrude on that sketch. The dimension is also 12 from the plane up. Okay, I hide this plane and then I go to the first sketch, which is the curve for creating the connection between the two discs. You see the dimensions. I use cartoons, as I mentioned in detail to you in my tutorial 199. You can take a look there to see how I work on this job. This is my hobby job. I am 78 this year, my friends. 78. You can number from 1 to 78 to see how old I am. Good. Then we respect that dimensions, and F7 to see inside. I create a spline. Spline, the type is interpolation, but to do this I need points. I prefer to start with points. 1, 2, 3. These two are on the same vertical, which is horizontal. This one with this one. Now you see they are on the same vertical, and I project the both generators of these cylinders, because I put on the same horizontal, this is horizontal, the 2 points with the midpoint of the generator. Okay, dimensions are 50 and we need 2 dimensions. That dimensions are for the placement of this point. The distance between these two horizontal is 1 to 0. On vertical is from up 90. It was almost here. Good. Now the spline. The spline, which starts from the superior point to the midpoint and to the bottom. It is still fully constrained, as it was before to create the spline. Finished sketch. Now I know that this is the spinal curve for a sweep of a circle. Yes? So that I need to create a plane perpendicular to one of the 2 ends of this spline. Plane, I select the spline and I select one end. Now here is a plane. It is small. We can enlarge this plane very easily. Auto resize. Auto resize. And you have a better vision of everything. I select the plane and F7 to see inside, because I have to create a circle with the center here. Look to my intended mistake. I start from this point, yes? Yes, of course, Professor. Yes, this is the point. Good. The diameter is 12. But now I see here that I have 2 dimensions. And I can move this circle. Oh, Professor, what did you do here? The problem is because I didn't project this endpoint. And now I can move the center to a green point, not yellow point. Yes? You see, this is green. Before it was yellow. Yes? Now I have a fully constrained sketch. Be careful with these minor problems because they can create problems. Good. We apply sweep, my friends. The circle is already selected and I select the profile. Select curve or edge. Curve. We have a curve here. Okay. Nice. Very nice. Visibility. Fillet 2 millimeters for this, and this, and also for this. Good. Okay. Now, as you saw, we must place this small cavity so that I create a new sketch in the plane, in this plane. You follow me. F7, line, a small line from the upper end to here, an arc. You see the arc is tangent, and go back to the center and close. No. The problem is that this is not placed okay, this is not okay. Why? Because I have to project the upper face and make collinear this line with this line and make coincident this point with this point. The angle is 30 degrees and the radius is 2 millimeters. The distance between this, you see, 1 dimension is necessary to fulfill the requirements. Dimension from this point to this point is, to this line, is 54. Now this is fully constrained. I apply center line to this line because I want to apply revolve. So we have here a line, an arc tangent to the line, a center line and an end to this closed sketch. Finish sketch, revolve. Inventor knows what happens here. He has a profile and an axis, but I have to apply cut. because I want to cut the part, not to add or join the new feature to the part. Good. Now I apply material which is steel cast. You see? Steel cast. But the aspect is not good. So that I go here and I apply also steel cast to have this texture. And I make something new. I apply a color to these two faces, two surfaces. The color is red. Okay? Okay. Not okay. We don't want to see these lines when we create the assembly. To do this, we go to Tools, Document Settings, Settings, and not shaded with edges, but shaded. Okay. Okay. Nothing happens here, but you will see when we create the assembly, the object is without these lines. You can apply also now the same visual style, shaded, not shaded with edges. But if you apply only here, you will find the object as shaded with edges, because this is temporary. Using this is temporary. Using Tools and Document Settings is permanent for this part. Okay. Now we go to the other component. We have here the next sketch, and we start from the center point. You see dimensions, radius 2, radius 1, diameter 2.5 at this end. This radius of 40 is also here the same radius. Diameter of 12, diameter of 80, and distance of 60 to this center. Let's create this object, this new object. New standard millimeters, start sketch, X, Y, circle 80, 80, but with the center over the center point. Then we create an arc to somewhere, radius 40, as I said, but tangent to the circle. Line horizontal, line vertical. This is enough for the moment. Center line. Y to place the dimension of 12 as a diameter. This line must be coincident with this point. And another thing, I want this to be tangent to the next, so that I place on the same coincident this point with this small line. Now I have a dimension here, yes? If I try to place this dimension from the line to the center, I obtain this message, because if I accept, this is an informal dimension, not a useful one. Okay, now another circle somewhere here with the radius 2, placed on the same axis at a distance of 60 from the center, from the circle. 60. Another arc from one circle to the other with radius equal, but let me place the tangency and equality, this arc with this arc. Good. Now I extend that line after I trim the circle. I extend. You can apply extend by using the tool trim. How? Keep pressed the Shift key and you apply extend. Yes? And vice versa. If you want to work with extend, you can go to trim by pressing and keeping pressed the key from the keyboard, the key shift. Okay, I still extend. I press shift and I apply again click. Now I use trim. I still use trim and I apply a fillet. Where is fillet? Here it is. With a radius 2, the default radius, and I have that dimension. There is a dimension missing. Yes, it was presented there. From this axis to, you see the symbol, not this one, but this one. Diameter of 2.5. Now I have fully constrained, finished sketch, and revolve. Okay. The next sketch is this one. Only 2 dimensions. Yes, but this one is perpendicular on the face and this one is perpendicular to the vertical. 2 important constraints. let's apply. We create a new sketch in the plane, this plane. F7, two arcs. The first one starts, you see, green, yes? Now we have automatically projected the face, upper face, so that we can I don't find perpendicular, but I apply perpendicular between these two, yes? The upper radius is 78, as you saw. 78. Now from that point to this point on the vertical, I wait to see tangent. This is tangent, yes? And now I place on the same vertical, which is horizontal, the same vertical between this point and this point. A radius of 190, and once again this point must be placed on the same vertical with the center point, you see, to obtain that perpendicularity here. Vertical is horizontal. Now is okay. Vertical is horizontal because I don't want to use this view. I want to use my first start. Fully constrained. Finish sketch. Another sketch is this face. End sketch. And then what? Sweep, my friends. This was selected, you see here profile is selected, and Inventor waits for me to select a curve or an edge. I select this curve. Join, not cut. Okay. Good. The last is the sphere. There with the same diameter as this one. I use this face because I draw a circle with diameter 80 a line, a vertical line, this time is vertical, which is coincident with the center point, this center, not center point. It is not this center point, yes? That center point is somewhere up, you see where. Okay, trim, center line, and revolve. Select axis, and I have the other sphere. Here is a fillet of 40, my friends, 40. Fillet 40 here. Okay. Once again, I want to have a model without edges, shaded. because all edges are tangencies. The material is brass, B, soft yellow brass. Now we have edges, but they will be not present in the assembly. Now we have to save the parts. This is the stand. Save as stand after. And the other one is save as eccentric mass. Eccentric mass after. Good. We create the assembly. Standard millimeters IAM assembly. Place simple, not from content center. Place stand after, ground it at origin, and eccentric mass no matter where. You see, this is very random placed here. The only constraint is the midpoint of this sphere to be coincident with the midpoint not of the circle but the sphere here. Yes, you see? Now we don't start with these two objects one through the other, anywhere, anyway, but not interference. For instance, this crazy position. Yes, we can choose any position. We go to environments, we apply dynamic simulation, we activate dynamic simulation, and now if I want to play for 1 second this assembly, I see nothing. Neither me nor you. Yes? Why? Because there is no force here, my friends. Is any force placed somewhere? No. What force? Gravity. Gravity. And I have to select the direction of gravity. The direction is the axis of the base disk. The axis, the direction is up. I don't want to be up. Nothing is going to the sky. I change the direction to the bottom. Okay. Now we have another situation here. But I don't want to see this, my friends. Why to see this? To escape from this, we apply click on this. Yes, this is the solution. We'll use it immediately. Good, let's start the movements. Oh, it's interesting, but only 1 second. Let's apply 5 seconds. 5. And go. You see, there is interference now. I can show you immediately. You see this moment. Yes, look here, this is interference. What is this? How to do for having a natural movement? We have to apply to insert a joint, but this can be done by selecting construction mode. Now I work in this environment where the movement are controlled by the dynamic simulation module, so that I click on construction mode, and now I am free to make anything I want. I insert the joint, not spatial but 3D contact. When you find a 3D contact between these two, only two objects, you have to, Inventor, have to change the movement to make a contact. Now I didn't finish this inserting. I have to select component 1 and component 2. Component 1 is any one, no matter which is the first or second. Yes? Good. Let's see what happens. See? Now we don't have any interference. Once again, I will change the angle, and you see there was a contact before. You can see contact even if you get out. Look. I try to create a contact, and you'll see that I have opposition. See? This is limited because of that joint. Good. Do you want to see a trajectory? Yes, I want. If you want, you will use trace. Trace, which asks you for part feature in movement. This is that feature, and you see now here point. This is in the middle of the sphere. Yes, just in the middle. And I want to see trajectory. Okay, go on. Now we have a trajectory of that center. Once again, you will see that that trajectory is on a sphere. Now you don't see, but if I change the angle, you'll see that this is a sphere with the center and this point. But how can I escape from having a trajectory? Very easily. You activate output grapher and you develop the tree of entities. You see I am not in construction, outside of environment, of this environment. When I click here, I am outside and I cannot select these elements. Trace, delete, and now we don't have any trace. Very interesting. How can I make slow motion? Slow motion you can create by using construction mode and changing this number of images per second by increasing the value. For instance, 2000 instead of 500. And now you'll see slow motion. Yes, and you can study better the movements. I'll be back with other dynamic simulation tutorials, and you will find out other things about. You always can download my general index table to see everything about my tutorials. You are invited to see that table by opening it, seeing everything in this table. You see you have observation here, anything you download, and you have this Excel file. Now tutorial number 249 is the last one, and this one will be the next one. Yes, where you see DS, dynamic simulation. Dynamic simulation, you have a lot of these tutorials. If you click on any link here, you see the tutorial. That's all for today. Thanks for watching. Bye bye.